In the previous video, we focused on the copy node. In that case, we're going to look at the instance node. So the main difference between the copy node is that this node simply keeps one copy of its left input. We'll not try to reevaluate it for every point, but we can still apply many transformations inside the shader. So the first advantage is because it does not reevaluate, we can use many more copies. So let's simply try to increase the size of this plane. And we can even use a scatter to have even more flexibility as to how many points we want. So in that case, we default to 100 points, and there is it updated almost automatically. So there is really little weight into the amount of operation that can do. So we can even increase that. So let's say we have 1000, and I'm also going to keep increasing the size of that plane. So again, this was very, very fast, and we can keep increasing that to quite a high number. As you can see, we have a large crowd now. But let's go back down so we can actually see what we're doing, and we can go to 1000. So now let's try to simply vary the scale on each of them. So what we have to do now is to go inside the material, and what we can see inside the instance transform, you can pipe instance scale, instance orientation, and instance position. So let's focus on instance scale. So let's create an attribute, call it instance scale, which is what the instance node creates for us. And if I pipe into here, nothing changes. But I want to multiply that, and I want to have it different for every single node. So if I go back to the scatter node, we can see that it creates an ID attribute for us. That attribute, if I look at the spreadsheet, varies, is 0, 1. It's different for every single point. But what I don't want it to go to a high value. I want it to go between 0 and 1. So I'm going to use the attribute normalize. Attribute normalize. And I'm going to rename it to IDN so I can keep a copy of both. Now, if I go back in the material, and I'm going to create an attribute, call it IDN. I'm going to rename this so I don't lose sight of what it does. And if I multiply the scale by it, now I only have everything turns to 0. And this is because I forgot to give the ID. Like if I look at the attributes carried on by the instance node, IDN is not there. That's because I need to specify it. So I make sure I specify it here, and now you can see that it is right here. So I go back to the material, and actually I don't need to go back to it. I can see that everything is, you can see variation in scale. And I can carry on doing more operations. So let's say I want to remap, instead of having everything from 0 to 1, I can use a fit node, and I can give my minimum scale. So some are not going to be too small, and my maximum value, and so on. I can keep editing those values. And so let's say we want to animate that scale. So in the globals, we have the frame here. So let's say we're going to use a sinus, and I'm simply going to multiply the output of the fit node with the sinus. And now if I play, everything moves really fast. So I still want to lower the speed of that, so I'm still going to multiply the frame by a lower value. So let's say this, and here is what we have. So we can see that we have negative scale. So let me just put an absolute here. Maybe not have everything so slow. And now we can see that the scale keeps changing. And how about we add an offset so that each deer, they don't all oscillate all together. So we can simply pipe a value here. We can base it again on this. So I'm going to simply move this here, put a different fit. And let's say I keep this minimum, but I put the maximum to 100. And now we have all of them being very different. And we can now even increase the number of deer that we have, and it will have almost 0 impact on the performance. So if I put 10,000, and you can see that this keeps moving like this. So that's what the instance node does. It will allow you to create a material that is very powerful, that allows you to have many variations for every instance with very little impact on the performance.